Assalamualaikum warahmatullahi wabarakatuh. In this chance, I will explain about my research, detailed fabrication of electrode of supercapbattery based on aluminum oxide, activated carbon, aluminum foil cathode, and Se carbon black nickel from anode. And the authors is Prof. Markus Diantoro, Dr. Nasikhudin, Dr. Risa Suryana, me Adisnya Nurul Hidayah, Nadea Catur Nurmayanti, and Prof. Worawat Meevasana. The introduction, the increasing energy crisis worldwide due to scarcity of fossil fuels, global warming, pollution, and environmental degradation has encouraged the development of energy storage technologies that have high performance, cost-effective, environmentally friendly, and sustainable. The development of energy storage media is one solution to deal with these problems, but the challenge is how to make a device with high specific capacitance, high energy, and power density. The devices that we know so far is battery and supercapacitor. Battery has a kind of not eco-friendly, so cycle life, low power density, and high energy density. And for supercapacitor, it has a characteristic of long cycle life, high power density, short charge time, eco-friendly, high electrochemical reaction, fast redox reaction, and low energy density. For the material that I used is aluminum oxide that has a characteristic like high thermal conductivity, high corrosive resistance, good chemical stability, high specific surface area, and low electric conductivity. And for activated carbon has a high specific surface area, good chemical stability, high electric conductivity, good cyclic stability, and long life performance. For anode materials like silicon has a high capacitance, low operation voltage, and environment friendly, but silicon has a big volume expansion on electrochemical process. And the carbon black has a characteristic of high thermal and electric conductivity, high specific surface area, and good cyclic stability. So in this study, the effect of the addition of aluminum oxide on the morphology structure, crystal size, functional group, porosity, and electrochemical performance will be studied to get a combination of supercapacitor devices with high specific capacitance, energy density, and power density. The materials that we used is activated carbon, carbon black, aluminum oxide, silicon, AT for NPF for electrolyte, PVDF, gold fiber separator, and nickel foam substrate and aluminum foil substrate. This is the methods that we use. We're using a blending method. First, we prepare the materials with the ratio of active 10 and 10 with active materials, conductive materials, and binder. The active materials here is aluminum oxide and activated carbon, and then stirred 1 gram La133 binder with DI water 3.5 ml at 300 rpm for around 1 hour, and then add 0.1 gram carbon black and stirred with 500 rpm for 1 hour, and add an active materials with total mass of 0.9 gram. The solvent stirred for 24 hours. And then for the data plate calibration with scale of 20 micrometer, and then vacuum process of substrate, the homogen solvent coat on substrate. After this, heating the samples at 100 Celsius for 50 minutes, and then cut the samples in a circular shape. This is the fabrication of coin cell to check the performance of these materials. And then this is the method to make an anode of Se carbon black. We use PVDF binder and DMS TMSC solvent. And then we fabricate samples on nickel foam substrate with micropipette like this, and then we can make a pressure to make a sample more thin than before, and then the samples is going electrolyte like the last picture. And then this is the analytic methods we use as RV characterization, FTAR, SAM, and newer PTS 5000. The newer PTS is used to check the performance of the supercapbattery. Result and discussion. First, X-ray diffraction. This is the SRT pattern of aluminum oxide Ac aluminum foil with aluminum oxide composition of 0 and 10%. The diffraction pattern form is dominated by amorphous arrangement, which shows the structure of activated carbon. The diffraction peaks of activated carbon are shown at angles of 2 theta of 26.50 degree and 43.36 degree with HKL planes of 002 and 100. In addition, the diffraction peak of activated carbon at an angle of 2 theta 38.47 with the HKL 111 plane. It shows the diffraction peak of the aluminum foil substrate used. And this is the SRT pattern of SA carbon black. The diffraction patterns of produced by the samples are in the HKL 111, 220, 311, and 400 planes. With GCPDS data number 27. Compared to SE nanoparticle, the diffraction pattern of the SE carbon black PVDF thin layer form has a lower intensity. So for the sample, the crystalline size of 0 aluminum oxide and 10 aluminum oxide has increased, and the crystallinity also increased, while the crystalline size is decreased. And then it is the FTER characterization. The FTER characterization shows a wave number at 30,529.73 until 1,288 centimeter. That indicates the absorption functional group between OH, CH, CC, and ALO. And the next is FTER of thin film SE carbon black. It shows the wave number between 3371.57 until 1141 centimeter. That indicates the OH, CH, CC, and SEO vibrational group. The next is scanning electron microscope characterization. From the analysis carried out, is noted the particle size distribution of SE powder is 60 nanometer. This result of the SE particle size accordance with the research of Tian et al., which suggests that the distribution of SE particle range from 20 until 60 nanometer. The porosity of the supercapacitor is increased, while the composition of aluminum oxide is also increased. And then in the image A, there is a pore with a diameter of 4.3 nanometer, which shows the pores of the nickel foam substrate. The activated carbon has a morphology resembling a sheet lamp and has large pores. And then the addition of aluminum oxide makes the pores of the activated carbon covered by metal. And the last is GCD characterization. Based on the resultant justice graphic analysis, it can be processed to determine specific capacitance, energy density, and power density using this equation. And for the sample, When the composition of aluminum oxide is increased, so the capacitance, energy density, and power density is also increased. And the supercapacity devices shows a superior performance with specific capacitance and energy and power density is higher than another sample. So the conclusion is the addition of metal oxide mass to the electro composite causes a decrease in crystal size and increases the degree of crystallinity. Same analysis show the porosity of thin film supercapacitor increases with the metal oxide addition at 10% composition. And for KCC analysis show that the performance of the supercapacitor electrode increases with increase in the mass of aluminum oxide. So this is all that I can explain. Thanks for your attention. I'm sorry if there is a mistake that I make. Thank you and wassalamualaikum warahmatullahi wabarakatuh.